Section 5.4 and 5.5 deal with parallelograms. 5.4 is just kind of the vanilla, regular parallelograms. And then 5.5 is special types of parallelograms. So in your notes, get these titles in, 5.4 and 5.5, and then set up a new sheet of paper for some notes on parallelograms. So first, section 5.4, properties of parallelograms. We'll start with just recall the definition of a parallelogram. A quadrilateral is a parallelogram if it has parallel opposite sides. And we can abbreviate parallelogram with the parallel symbol O-gram. Now let's show you an example.
A parallelogram ABCD. Actually, ABDC. I guess I got those switched around a little bit. But if you take and drag the points B and C and A, you'll notice that these side lengths, 9 and 9, the opposite sides are always congruent. Likewise, if we change around the other sides, the opposite sides are always equal to each other. Next, if you take a look at the opposite angles, so 62 and 62, opposite angles are congruent, 118, 118. You'll also notice that these two angles, 62 and 118, they're supplementary. And that's true because we've got two pairs of parallel lines and cut by transversals, so consecutive angles are always supplementary. A and C are supplementary, C and D are supplementary, D and B, A and B. Last, take a look at these diagonals. So they're not congruent in length, right? Because right now it looks like AD is longer than CB. But what you should notice is that they bisect each other. So the distance from A to the midpoint, let's call it E, is 7. Let's just move that over there. And so the distance from E to D is also 7. From C to E is 4. And from E to B is also 4. And that's true regardless of what the original shape looked like. Let's try and move this around a bit. So the diagonals will always bisect each other in a parallelogram.
So to get those in your notes, the conjectures for parallelograms, if we have a parallelogram, then both pair of opposite sides are congruent in length, both pair of opposite angles are congruent in measure, the consecutive interior angles are supplementary, and the diagonals bisect each other. Make sure you have these conjectures as well as the definition in your notes for parallelograms. Next, section 5.5, 5.5, special properties of special parallelograms. First one we'll talk about are rhombus, or rhombi. So a quadrilateral is a rhombus if and only if it has 4 congruent sides. So here we have a picture of a rhombus. You'll notice the congruence markings show me that I have all 4 congruent sides. You'll probably want to include that in your notes as well. You can sketch a rhombus, or you can use one of the geometer tracers. So the plural of rhombus is rhombi. There are some other words that follow that same type of plural rule, like cacti for cactus, or octopi for octopus. Just kind of a fun plural tidbit there. Some things about rhombi. All rhombi are also parallelograms. They're special types of parallelograms. Because of that, all rhombi share the same characteristics that parallelograms have. In other words, all pairs of opposite sides are congruent and parallel, so you can add in those parallel markings. The opposite angles are congruent, so you can add in those congruence markings. Remember that the consecutive angles are supplementary. The diagonals bisect each other. And one new thing is that the diagonals are perpendicular. Two new things. The diagonals are perpendicular and the diagonals bisect the opposite angles. So rhombi are lots of fun. You can create rhombial tilings no need to get this in your notes. It's just kind of pretty fun little pictures showing sort of strange three-dimensional shapes going on with rhombial tiling, kind of nifty designs for you. So next, a couple of examples with rhombuses. Example number one, I'd like you to sketch a rhombus. Again, use the geometer tracer, might help you out. We've got rhombus RHOM. If you include the diagonals, then let's say we're given that angle HRM is 82. Then how big is angle HMO? Well, we know that consecutive angles are supplementary, and so that means that blue angle there, RMO, would be 98. Then, because we know diagonals bisect opposite angles, the unknown angle would be 49 degrees. Let's get another example in your notes. Here we've got another rhombus, and let's say that those two little angles are given to us, 3x minus 10 and 5x plus 20. The key thing is that the diagonals are perpendicular. And so that little tiny triangle down below is actually, well, it's a triangle, and so all three of the angles add up to 180. So we have 3x minus 10 plus 5x plus 20 plus 90 equals 180. And then we'll solve in the usual way. Just combine like terms, subtract 100, divide by 8, you get that x is 10. So connected with this, we also want to talk about squares, and we'll talk a little bit more about the strict definition for squares. But remember, squares have 90-degree angles. And squares are special types of rhombi. And so if that little tiny angle is 2x minus 13, that angle is half of a 90-degree angle. In other words, 2x minus 13 is 45, and so that means x is 29. Let's throw another couple of definitions at you. For rectangles, a rectangle is a special type of parallelogram. It has all right angles. And because rectangles are parallelograms, they share all of the special characteristics that parallelograms have. In other words, opposite sides are congruent and parallel. The angles are, opposite angles are congruent. They're also all 90 degrees. Consecutive angles are supplementary. The diagonals bisect each other. And then one new piece of information, the diagonals are congruent in length. So let's take a quick look. Oops. We've got an angle, or a rectangle ABCD, and we want to solve for both x and y. We know that angle A is a right angle, so 5x plus 8 and 3x plus 2 together would have to make 90, so that means x is 10. Then, to figure out y, I know that angle BAC and DCA are alternate interior angles, which means they are congruent. And so, oops, didn't show up quite right. 3x plus 2 is equal to 6y plus 2. Sub in your value of x, you should get that y is 5. Finally, so rhombi and rectangles are related to each other. And we have a square if the shape is a combined rectangle and a rhombus. To put it another way, if we have a square, that means all of the angles are right angles and all the sides are congruent. Furthermore, the diagonals are congruent in length, they're perpendicular, and they bisect each other.